The dream of flying faster than sound has always fascinated humanity. For decades, scientists, engineers, and pilots have pushed the limits of speed, performance, and design to create aircraft that can break the sound barrier. But one of the biggest challenges of supersonic travel has always been noise. When an aircraft exceeds the speed of sound, it creates a loud sonic boom that can be heard over vast distances. This sudden explosive sound can startle people, damage property, and disturb wildlife. Because of that, governments around the world placed strict limits on supersonic flight over land. NASA's new aircraft, known as the X-59, aims to change that story forever. This experimental airplane has been designed not just to fly faster than sound, but to do it quietly, almost silently compared to traditional supersonic jets. The X-59 represents years of research in aerodynamics, materials science, and acoustic modeling. It is not a commercial airliner or a military fighter. It is a scientific tool built for one mission: to prove that supersonic flight can be made quiet enough to be allowed. Over land once again. The origins of the X-59 project go back to NASA's long-term program, known as the Low Boom Flight Demonstrator Initiative. For many years, NASA engineers studied how shock waves form around an aircraft's body when it flies faster than sound. They discovered that by carefully shaping the aircraft's nose, wings, and tail, it was possible to control how those shock waves merge and spread through the air. The goal was to turn the sharp, explosive sonic boom into a softer sound, something like a distant thump, gentle enough not to disturb people on the ground. To bring this vision to life, NASA partnered with Lockheed Martin's Skunk Works division, the same team known for building some of the most advanced aircraft in history, including the SR-71 Blackbird and the F-117 Nighthawk. Together, NASA and Lockheed Martin began designing a completely new kind of supersonic airplane, one that would not only break the sound barrier, but also reshape how that barrier is perceived. The X-59 is a sleek, needle-like aircraft about 30 meters long with a narrow 9-meter wingspan. Its most distinctive feature is its extremely long and pointed nose, a design that helps spread out the shock waves before they reach the ground. By stretching and reshaping those shock waves, engineers have reduced their intensity, transforming the loud double boom typical of supersonic jets into a much softer and quieter sound. Every detail of the X-59 has been engineered for this purpose. Its fuselage is designed to distribute pressure changes evenly. The wings are placed low on the body and are shaped to minimize the formation of strong shock fronts. Even the placement of the engine, mounted on top of the aircraft rather than underneath, helps redirect noise upward into the sky instead of down toward the ground. The result is a flying laboratory that embodies decades of aerodynamic research and innovation. The X-59 is powered by a single General Electric F-414 engine, the same type used in some modern fighter jets. This engine allows the plane to reach speeds of about Mach 1.4, which is roughly 1,700 kilometers per hour at cruising altitude. But what makes this aircraft special is not its speed. It's the silence that comes with it. At that velocity, a traditional jet would create a deafening sonic boom. The X-59, in contrast, is expected to produce a sound as mild as a car door closing, about 75 decibels on the ground. One of the most striking things about the X-59 is that the pilot has no forward window. The long nose of the aircraft makes it impossible to have a traditional cockpit view. Instead, the pilot relies entirely on a high-tech system called the External Vision System, or XVS. This system uses high-resolution cameras mounted outside the aircraft, feeding real-time imagery to 4K monitors inside the cockpit. With this setup, the pilot can see the sky and runway with crystal clarity, even though there is no glass window in front. This futuristic design choice isn't just about aesthetics. It's about safety and efficiency. Without a traditional windshield, engineers could extend the nose further, improving aerodynamics and shockwave control. At the same time, the camera-based vision system provides better visibility than most traditional cockpits, especially during takeoff, landing, and low-altitude operations. The development of the X-59 has been a complex journey involving thousands of hours of computational simulations and wind tunnel tests. Engineers used supercomputers to model how air would move around the plane at supersonic speeds. Every curve, angle, and contour of the fuselage was analyzed to ensure that shockwaves would behave exactly as predicted. Even small adjustments, a few millimeters in the nose shape or a slight change in wing curvature, could significantly alter how the sound reaches the ground. The construction of the X-59 began at Lockheed Martin's Skunk Works facility in Palmdale, California. The aircraft's structure combines advanced composite materials and lightweight alloys designed to withstand the stresses of high-speed flight. Precision was critical. Each component had to fit perfectly to maintain the intended aerodynamic shape. The assembly process took several years, with teams from NASA and Lockheed working side by side to ensure that every system functioned flawlessly. Beyond its physical design, the X-59 incorporates sophisticated flight control systems. Supersonic aircraft can be unstable at certain speeds, especially when transitioning from subsonic to supersonic flight. To manage this, the X-59 uses digital fly-by-wire controls, an electronic interface that interprets the pilot's inputs and adjusts control surfaces automatically to maintain stability. These systems allow the aircraft to perform smooth, controlled maneuvers even at extreme speeds. Once completed, the X-59 will undergo an extensive series of ground and flight tests. The initial goal is to verify that the aircraft behaves as predicted in supersonic flight and that its noise signature matches NASA's models. During testing, sensitive microphones and sensors will be placed on the ground along flight paths to record the intensity and pattern of the sound created by the aircraft. Engineers will then compare those recordings to computer predictions to confirm the success of the quiet boom technology. But the X-59's mission goes far beyond engineering data. NASA plans to fly this aircraft over selected communities in the United States to gather feedback from people living below the flight path. Residents will be asked how loud the aircraft sounded, whether it was disturbing, and how acceptable it would be if commercial supersonic flights produced similar noise levels. The results of these surveys will be shared with international aviation regulators to help shape new rules for future supersonic travel over land. If these tests are successful, they could lead to a major shift in how aircraft are designed and approved for high-speed flight. For the first time in more than half a century, supersonic air travel over populated areas might become legal again. That would open the door to a new generation of fast, efficient airliners capable of connecting cities at unprecedented speeds. The X-59 is more than a prototype. It is a bridge between the past and the future. It draws lessons from the era of the Concorde but uses modern technology to solve the problems that ended that program. The Concorde was a remarkable engineering achievement, but it was also noisy, fuel-hungry, and expensive to operate. The X-59 aims to demonstrate that a quieter, more efficient alternative is now possible. This project also represents a broader shift in NASA's mission. While the agency is best known for space exploration, it has always been deeply involved in aeronautics research. The A in NASA stands for aeronautics, and projects like the X-59 remind the world that NASA continues to shape the future of flight here on Earth. For engineers, the X-59 serves as a flying laboratory, a testbed for new materials, digital control systems, and aerodynamic techniques that could influence many types of aircraft, not just supersonic ones. The lessons learned from its development could improve efficiency and noise reduction across the aviation industry, even the data collected from community. Response flights will help future designers understand how people perceive sound. It's not just about decibels. It's about how human ears and minds interpret different kinds of noise. NASA's goal is to create a complete understanding of quiet supersonic flight, both from a technical and psychological perspective. The timeline of the X-59's progress reflects both ambition and patience. Initial design studies began years ago, and full assembly took place in the early 2020s. As of now, final testing and first flight preparations are underway. NASA expects the first official flights to happen soon, marking a new milestone in aviation history. When that first flight occurs, the data collected will shape the next steps. If the sound levels match predictions and community feedback is positive, The results will be shared with organizations like the Federal Aviation Administration in the United States and the International Civil Aviation Organization globally. Those findings could help create new noise standards that will define the rules for future commercial supersonic aircraft. At its core, the X-59 is a message to the world that innovation is not just about going faster, it's about going smarter. By mastering the physics of sound and air, NASA and Lockheed Martin are proving that technology can overcome the limits once thought to be permanent. The sound barrier is no longer a wall. It's a challenge waiting to be redesigned. The journey of the X-59 is a reminder of how far aerospace engineering has come. From